Today what we're going to work on are finding key features of polynomials again. However, yesterday we looked at finding them when given a graph. Today what we're going to do is look at them or find those features when we are given a expression versus the graph. Now, just like with functions, if I want to find key features, I'm going to put it in a graph. So it's going to immediately go to Desmos, and all of this work is going to be done through Desmos. So x to the fourth minus 2x cubed minus 3x squared plus 5x minus 3. In these situations, right, I don't worry about putting a y equals because I'm not given one. You can, it's not going to make a difference. So if you're worried or concerned, like, well, when do I put y equals versus when do I not, right? If you see it, it doesn't change whether I do or do not have y equals. Okay. Again, I said in behavior I like to do first. So as x goes to negative infinity, y goes 2. So if I look at the leftmost piece of the graph is going up to positive infinity, and as x goes to positive infinity, or the right part of the graph is still going up to positive infinity as well. After that, I like to pick out my maxes and my mins. Okay. And the cool thing about Desmos is that it'll actually tell you these values. All right. Now I'm gonna just select my mins to start with. So I have negative 8.027 and negative 5.029. Remember, I highlighted the smallest one for min, and then for my max, it'll be negative 1.382, and the biggest value it goes to is positive infinity. Again, infinity is bigger. And your range is made up of your maxes and your min, the absolute values. So negative 8.027 to infinity. Infinity always gets parentheses. One thing you may want to do is just make sure there's no breaks, gaps, or holes in the graph. I then do domain, left to right, negative infinity to infinity, and I change this again if there's breaks, holes, or gaps, which there is not. Once I do that, I go to roots and zeros. Remember where it crosses the x-axis, negative 1.783 and 2.586. Multiplicity on these are odd because it goes through, it does not bounce. Remember, if it would have bounced, it would have been an even multiplicity. So again, quick recap, just take your polynomial, put it in Desmos, get your graph. Once you get your graph, just run through here and do the key features in most confidence to least confidence. As far as these other two examples, I'm going to let y'all do those for classwork today.